Welcome to this video on the topic of exponentials. In this video, we're going to have a look at how we can go about sketching exponential relationships. Now, an exponential relationship can be easily sketched when it's arranged in a general form as shown over here. We have y equals k multiplied by a to the power of x minus c plus b. Now, each of the variables within this relationship here affects the overall shape of the exponential as it's sketched or graphed, depending on which one you do. Now, each of these variables can be given a specific name. Now, starting at the simplest one, we have a, and we refer to this as the base. We refer to this as the base as this is the variable that undergoes successive multiplication as defined by the exponent up here. Now, next to the base, we have k. We refer to k as the vertical dilation factor. Moving along, we have c over here. C refers to our horizontal translation. And finally, we have b here. B being our vertical translation. Now, I'm not going to go into detail as to what all of these actually do at this point in time. Rather, we're going to come back to this and learn by discovery. Now, when we're dealing with exponential relationships, there's four shapes that we can expect to see as we're graphing it. Now, the first shape that we can see is when we have a k value greater than 0 and an a value greater than 1. So k over here is greater than 0 and a, so our base over here, is greater than 1. What we see is that as x is increasing, the values of y become very large. So as x increases, y becomes very positive. Moving along, we have k is less than 0 and a is greater than 1. So you can see that the graph over here resembles that. As x is increasing, what you notice is that the y values become very large but in a negative direction. So you can see y becomes very negative. So k less than 0, a, or our base, greater than 1. Moving across, we have a value of k that's greater than 0 still, but a is between 0 and 1. Now, looking at this, we start off where as x increases, as we start off on the left, as x becomes more negative, the values of y become more positive, but as x increases, the values of y begin to flatten out. So y is decreasing as x increases, but the values of y begin to flatten. So y becomes less positive and flattens. And then finally, we have a k value less than 0 and a between 0 and 1. You can see that you start off being really negative, but again, as x increases, the values of y begin to flatten. So y becomes less negative and becomes flattened, or becomes flatter. Alright, now that we've had a look at what the exponential relationship might look like as we graph it, let's actually have a look at how we go about graphing them, or go about sketching them, I should say. Now, to do this, we're going to do it in about 6 steps. First example here, we have y equals 2x, or 2 to the power of x minus 3. Now, first thing I'm going to do here is I'm going to try and observe any translations that are going on here. So I'll write translations, and then I'm going to set up for my vertical. And now, simply jumping into this, I can see that my vertical translation, characterized by the -3 here, is a -3, and my horizontal is at 0, because usually I'd expect to see x minus something, x minus c. So going up, we have vertical translation characterized by b. In this case, it's -3. And our horizontal, so x minus something. And because there's nothing here, then you can see it's horizontal of 0. Now, for this one, it's not too important, but it's a good practice to go through this because it will really help you when you're graphing other stuff. Now, using these translations here, what we're going to say is that our horizontal asymptote is going to be at y equals -3. characterized by this translation over here. So this vertical translation corresponds to the value of our y asymptote. Now, y asymptote being a horizontal line in this case, which I'll explain as we're graphing. Now, next step is we need to find the y-intercept of this guy over here. Or in other words, we want to find where our exponential is going to cut the y-axis. So it's this point here, 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 and here. So to do this, what I'm going to do is I'm going to show my full working out by rewriting the relationship again, y equals 2 to the power of x minus 3. And then I know that I'm going to expect to see the y-intercept when x is equal to 0. So going up here, all of this is 0. So to show that, what I'm going to write is let x equal 0. Solving this, I find when x is 0, y is equal to -2. So I can see that my y-intercept is at 0 and -2. Now for a single or simple exponential where I've only got a base and a translate or vertical translation here, I can start sketching this straight away. Now to begin the sketch, what I'm first going to do is I'm going to sketch in my horizontal asymptote, that being y equals -3. Drawing that in, I simply pan my line, and then on my Cartesian plane, I need to identify where I'm going to put -3. In this case, I'll say this is -1, -2, -3. Drawing in my line, remembering to use a ruler, I have y equals -3, like that. And half of the work is already done. Now next step is I need to identify my y-intercept, that being at y equals 0 and -2. So what I'm going to do is I'm going to mark that on my Cartesian plane. So I'll go 0, -2. And now because I've only got a single point marked, what I'm going to do is I'm going to go up. I'm going to match, based on what I have over here, I'm going to match what I expect to see the shape to be over here. Now looking at this, I've got 2 to the power of x minus 3. So what I really need to focus on is this term within the expression here, so 2x. So I can see that my k is implied as 1, so it's a positive k, and my base over here is positive. So I'm looking for positive k, positive base, and that's going to give me this shape over here. So all I need to do is I simply match this shape such that it cuts through this point here and it approaches this asymptote here. Drawing this in, I'm going to get something that might look a little bit like this, keeping in mind that it's a little bit tricky to do this on a computer. So this is my exponential shown here. Now verifying that this is the correct exponential that I've graphed, what I'll do is I'll bring up my calculator, I'll go into graph mode, then I'll key in this exponential, so 2 to the power of x, 2 to the power of x minus 3, and I'll key in the asymptote now as well, so that's minus 3. Graphing this, it's anyone's guess what it's going to turn out like, so I'll set up my V window. I want to observe between, let's say, minus 3 and 4. Graph, then I go to Shift, Zoom, Auto, and what you can see is that this is the exponential I've got here. Now checking that I've got the right points, what I'm going to do is I'm just going to check this intercept here. So using this intercept, I'm going to go G-solve, and then I'm going to go y-intercept, this guy here, and you can see I've got 0 and minus 2. So what I can confirm from that is that I've graphed this correctly. So we did this in about 6 steps. First one is we identify our translations. Secondly, we identify the asymptote. Thirdly, we discover the y-intercept. Fourthly, we plot, or I should say we graph the asymptote, or you could say sketch, but it's basically a graph. Fifthly, we plot the y-intercept. And finally, we match the shape. Finally, we fit the curve to the plot. So we identify one of these four curves, in this case it was this one, and we simply fit it to what we have here. So what we've done is we've sketched y equals 2 to the power of x minus 3 using 6 simple steps as shown here. Now moving on, let's go to something a little bit trickier. Y equals 3 times 0.25x to the power of x plus 1. Now once again, to plot this or to sketch this, we first identify our translations. We are going to have a vertical and horizontal. The vertical being this plus 1 over here, and the horizontal is going to be 0 again because it's absent. So you can just leave it at 0. And from that, we can see that our horizontal asymptote is at y equals, and it's this guy here, so it's y equals 1. Now next step, what we want to do is we want to find the y-intercept. So what we're going to do is we write it out, and then we synthesize when x is equal to 0, because that's where we know our y-intercept occurs. So we let x equal 0. Solving this, we discover that y is equal to 4 in this case. So we can see that our y-intercept is at 0, 4. Alright, now we're ready to start cracking. What we're going to do is firstly we sketch our y-asymptote, that being y equals 1. So what I'm going to do is I'm going to sketch in my horizontal asymptote. So using a ruler, I'm going to sketch this line in, and it's going to be y equals 1. Next step, I'm going to plot my y-intercept, that being at 0 and 4. So I go 1, 2, 3, 4, and it's going to be 0, 4, just like that. There we go. And then finally, what we need to do is we need to match the expected shape to the points that we currently have on this plot over here. So I've got 3, so our k is 3, and our base is 0.25. So going up, you can see that k is greater than 1, but a is less than 1. So k is greater, a is less, but still above 0. So we're going to get this shape over here. So y becomes less positive and flattens. So it starts out really big and goes down. Alright, matching that. And we wind up with something that sort of looks like this. If I were doing it again, I'd probably have less of this visible here. And yeah, so I'd remove some of this part here, just so it's clearer. Now checking that this is indeed the actual plot, I bring up my technology and I simply key in the exponential relationship as shown here. So graphing, and what I can see is it looks okay. It's probably a little bit steep over here, but that's alright. It's the overall shape we're going for, and I'll just check that I got this right here. So gsolve y-intercept, and lo and behold, it's 0, 4. So I've got it right. I'm pretty confident that this is the graph of this relationship here. Now, final one, we have y equals -2 times 3 to the power of x minus 1 minus 3. So we've got everything going on in this graph here, or this sketch here. Now to do this, we first start off by identifying our translations. And the vertical translation is -3. And the horizontal, as you can see, is it looks to be -1, but it's in fact 1. Now the reason for that is you can see x minus 1 here. And if you go up, we're expecting a minus here. So it's whatever this c is, we sort of ignore the negative and just take the value of c. So in this case, it is not -1, but rather it becomes +1. So it's just this here. We ignore that negative. All right, now getting the asymptote, we can see that it's going to be y equals -3, taking after this guy here. All right, next step is we need to find the y-intercept. To do this, what we're going to do is we write this out again, and then we're going to let x equal 0. Alright, now to this point I'm given a little tricky thing to do. Now rather than try and crunch this in my head, which I'm sure I can do, I'm just going to use a calculator so I'm less likely to make a mistake. So I get -11/3. And thus I can see that my y-intercept is at 0, -11/3. Just like that. Now I could use this information here and graph it just like I have done with this and this, but with this one here I want to be a little bit more accurate, and I can be a little bit more accurate because I've got more information to work with here. Notice how I've got this horizontal translation. What this means is that the graph over, let's say if this was translated by a +1, then the graph here would go in this direction. If it was negatively translated, then it would go in that direction. So we're expecting to see the graph below translated. So what would be here, shifted across like that. So doing this, what I'm going to do is I'm going to find where the would-be y-intercept would be. So to do that, what I do is write out this relationship again, and then I'm going to say let x equal 1. 1 being the value of this horizontal translation here. Solving this, you can see that we're going to default to a 0 in the exponent, and thus we get a nice clean number or clean point to work with or to plot. So we're going to get 1, -5. Alright, so I've got 2 points I can plot to then fit the curve. Now, graphing this, I can see that my asymptote is at -3. My y-intercept is going to be at -3 2/3. And then I've got this guy over here, so 1 and -5. So looking at that, if I were to graph this, the y-intercept would be, or the asymptote would be somewhere around, not there, somewhere around here, and then I'd be graphing in this region here. So what I'm going to do is I'm going to shift everything slightly upwards to conserve the space. So I'm going to draw an asymmetric Cartesian plane, asymmetric in the vertical orientation. Then I'm going to sketch in my asymptote. And now I'm going to put in my plots. So I've got, that is going to be -3 2/3, which will allow me to put it on the number line a little bit easier. So at 0 and 3 2/3, so this is 3 or -3, this is -4. So we're looking at around about there. And then the next point is 1 and -5. So this is +1 over here, and this is -5 over there. So the next plot is going to be about there. So what you can see is that simply by looking at this, I know that the graph is going to start here and bend outwards. So I don't even need to look at these reference shapes anymore. So fitting the curve to what I can see. Go. So we get something that should look roughly like that. It's not perfect because the tools I have on the computer aren't great, but it's going to look, or I expect it to look something like this. Now verifying that this is correct, we say up, we come to the calculator, go into graphing mode, key in the exponential, the asymptote, I graph it, and then I auto zoom it. I get something which sort of looks right. I got the shape right. Now I just check my y-intercept is indeed at -3 2/3. And if I go to gsolve again and go for my y value, if I put in a value of x equals 1, then I indeed get y equals -5. So what I can see is that I was successful in graphing this exponential over here. So in summary, what we had a look at in this video was how we can go about sketching exponentials using this general form shown over here. After that, we then discovered that we can sketch these exponentials using 6 steps. First one being identify your translations, identify your asymptote, discover the y-intercept, graph the asymptote, plot the y-intercept, and then fit the curve to what you have. And then finally, in the final example, rather than fitting the curve, we simply get a second point using the translation, and then we simply fit the curve based on the plot we see.